This is Brian Putt. There are many situations where we have two random variables that are binary. They're either success or failure. Examples might be two oil fields that are nearby. They may have a correlation related to them. If one's successful, the other is more likely to be successful, or vice versa. Or it may occur in drug development. You've got two drugs that are similar being developed. And if one's successful, it's more likely that the other will also be successful, maybe in a particular area or something of that nature. So these situations arise, and the question becomes, how do you deal with them when trying to look at economics of these variables in a Monte Carlo situation? So I'm going to show you one way of doing it. And so how do you normally go about this, getting the input for it? Well, you might go to your subject matter expert and ask them, what is the correlation between these things? Well, I'm not sure the subject matter expert understands what correlation is, but I think they do understand graphics. So first of all, let's define this. Let's look at this model. We have something called a correlation matrix. So in this case, the diagonal is always going to be 1. And this yellow cell refers to the actual correlation between the variables MJ1 and MJ2. Let's start off with no correlation. So using SIP math, we can generate an uncorrelated variable, and we can generate a correlated variable. Now, if this is no correlation, these two numbers across here and these numbers here are going to be the same number. Now, in our two cases, MJ1 and MJ2, we've said that MJ1 has a probability of success is 70%, and MJ2, a probability of success is 60%. So in this particular case, MJ1 is successful because this random variable of 0.25 is less than 70. In MJ2, the random variable is 0.98, which is larger than 60, and therefore it's a failure. And so we can look at the correlation of these two random variables that are in 0 and 1s. They're only 0 and 1s. And that correlation, rather than being exactly 0, which is what theoretically it should be, is really 0.04, which is very, very close. Also, the correlation of these two uniform distributions is 0.24, also very close to 0. And then when we come down here, what is the overall chance of both having seals or being successful if independent? Well, that number is simply the multiplication of 70% times 60%, or 42%. In this case, once again, we said they're uncorrelated, so we'd expect this number that we calculated based on these results to be also 42%, but it's 43, pretty darn close. Another way to think about this is, given this system of 0 and 1s, what's the probability that both are successful? Well, here we've calculated that. They're both successful 43% of the time. So if I plotted the results of these two random variables, RAN1 and RAN2, these are these two variables here, we find out that 43% are going to be successful, because this is the 70% for RAN1, and this is the 60% for RAN2. So all the dots down in this quadrant are successful, both of them. Up here, they're both unsuccessful, and here there's only one that's successful and one that's successful. So we can look at that. So now let's ask a question. What happens if we change this correlation to 0.5? So we'll change this to 0.5. It calculated 5,000 trials. And now this correlation of 0.5 has gone to 0.503. And the correlation between the 0 and 1s has dropped down to 0.36. And the chance of both seals being positive, or being the correlation of that, is 0.5, is 50%. So we got 50% of the dots, I think, are down here. And we can see that also down here, 50% are both successful. So now let's move to 0.75. So they're a little bit more correlated. Let's look what happens to these dots. They get a little bit squashed, right? They get squashed. So now the chance of both seals, if correlated, is 54%. And we can see the 54 down here. What happens at 1? You get a straight line. It goes from 0, 0 up to 1, 1. And if they're perfectly correlated, we only get 59% are actually both going to be successes. So I just wanted to share this model with you. If you're interested in seeing how more of it works, let me know. Oh, and I just to show that it's fully interactive, if I was to change this to 0.5, you'll see the red lines moved as well. Red lines moved as well. And we're back to 50% here. Both successes. So I think graphically, I think you can talk to your subject matter experts and they'll have a much better feeling for, yeah, that's what I really, that's what I was thinking about in my gut as far as both being successes. Thank you for watching. If you'd like to learn more about SIP math, I suggest you visit probabilitymanagement.org. They have a wonderful website with all kinds of tools there, shown down here, who they are. You can download models, and there's tools down here to include the SIP math toolbar itself. You might also read The Flaw of Averages by Sam Savage. And please visit my YouTube channel. I have over 80 videos that cover a wide range of topics to include uses of the SIP math tools, how to use the icons, cost and schedule risk analysis, portfolio analysis, value of information, lots of videos on that, and some mind testers. Hope you enjoy. Thank you.